In today's industry, the integrity of welded components is critical to ensuring safety and operational continuity. Non-destructive testing has evolved toward advanced techniques such as phased array ultrasonics, enabling more efficient detection and characterization of discontinuities. The objective of this video is to standardize the use of an automatic encoder and to develop an inspection plan using a dual transducer setup oriented toward the weld seam. Additionally, we will demonstrate automated scanning on a plate with known reference discontinuities. Let's get started. A scan plan is a technical document that precisely defines how an inspection will be performed on a weld, ensuring full coverage, repeatability between inspectors, and compliance with applicable codes and standards. This plan includes the weld geometry and the heat-affected zone, the range of angles to be used or focal laws, the coverage of the inspected volume, and the equipment configuration, including the number of transducer elements, their size and frequency, the wedge geometry, and the transducer position relative to the weld center line. These parameters ensure a reliable inspection with full area coverage and complete traceability of the results. Prior to creating the scan plan, we will configure the part to be inspected by accessing the app menu and selecting the joint type. In this example, we select a flat weld and press Next. Now we add a new part and select the corresponding joint preparation type, in this case a V-groove bevel joint, which can be referenced in the Weld WPS. Next, we configure the part dimensions. We set the plate thickness to 13.4 millimeters and select the material as low-carbon steel. We set the root opening to 12 millimeters. And we set the groove opening to 21 millimeters. These parameters allow the system to automatically calculate the bevel angle. We then proceed to set the crown height to 2.3 millimeters. We set the root height to 1.9 millimeters. And we set the penetration depth to 2 millimeters. We also set the heat-affected zone to 3 millimeters. We set the test piece length to 505 millimeters. And the width to 305 millimeters. Finally, we press Finish and assign a name to save the part configuration. To begin the scan plan, we select the number of groups to be used. In this example, we will configure 2 groups. For the first group, we select the transducer model, the wedge, define the transducer position on the left side, then press Next. Next, select shear waves, then press Next again. Set the scanning angle range, or focal laws, from 40 to 70 degrees, with a step of 0.5 degrees. Set the number of active elements of the transducer, from element 1 to 16. and set the focal depth to 20 millimeters. Next, adjust the transducer offset from the wedge edge relative to the weld center line. To ensure the ultrasonic beam covers from the upper crown edge to the midpoint of the weld. In this case, the calculated distance is 22 millimeters from the heat-affected zone to the weld center line. Select group 1 of 2 and adjust the focal depth. Now press Next to configure the second group. Select the transducer model. Select the wedge and define the transducer position on the right side. Then press Next. Select shear waves, then press Next again. Set the angle range from 40 to 70 degrees with a step of 0.5 degrees. Set the active elements from 1 to 16 and set the focal depth to 20 millimeters. Adjust the ET offset to 22 millimeters to cover the remaining half of the weld. Select group 1 of 2 to adjust the focal depth, then enable both groups to display them on screen. Press Next. Finally, configure the scan layout to A plus B plus C for both groups. Press Finish and confirm the parameter update in the system simulation. To begin the encoder configuration, run the autocontroller software as administrator. Once the software starts, verify the connections of the controller, the encoder, and the SyncScan 3 unit. When the status indicators turn green, press Continue. In the File menu, select the encoder configuration. For this example, select the Bandit model. Confirm the selection, and the software will automatically calculate the pulses per millimeter. Now we can begin the encoder standardization. For encoder calibration, select the model on the instrument in the Manager menu. In the encoder section, choose the model based on the encoder characteristics being used. For this example, select the LPS02EN04 model. Create a new setup and enter the reference travel distance, 1,000 millimeters. The instrument will prompt you to place the encoder at the starting position, that is, at the 0 reference. Once the sensors are in position, press Step 1 and move the encoder to the final position. Once the encoder reaches 1,000 millimeters, press Step 2 and return it to the starting position. Once the travel is complete, the instrument automatically calculates the pulses per millimeter required to cover the reference distance. Press OK and assign a name to this new setup. Finally, select the configured encoder. Then, perform a test to verify the distance traveled by the encoder. Set the distance to 1 meter and place the encoder at the starting position. Once the travel is complete and the same distance is confirmed on both the instrument and the software, scanning can begin. Before starting, It is important to note that the required instrument standardizations have already been completed. Sound velocity, wedge delay, sensitivity, and TCG curve generation based on the reference block in accordance with the applicable code. To begin scanning, go to the Scan option and adjust the range. The range should be set to display at least 2 legs of the ultrasonic beam, based on the thickness defined in the scan plan. For this example, set it to 50 millimeters. It is also important to check the E distance, which in this case is set to 22 millimeters. To do this, go to the Measurement option. Select point 2 of 3, E distance, and set the value to 22 millimeters. Now, go to the Display menu. Select the INDN option and enable Groove Display. This function allows us to view the weld profile within the sector scan. Go to Advanced Scan. Enter Setup and select the scanning method. For this example, choose the Positive Encoder option and select the previously standardized encoder named Test Bandit. And press the back button. Next, synchronize the software with the instrument for data acquisition. In the Autocontroller software, go to Control, select Scan, and press the Start button. From this point, begin the movement, and the system records the data in real time, generating the scan of the part as you progress. To save the data, press Finish and then Save. Assign a name to identify the file and confirm by pressing Enter. A well-defined scan plan ensures complete inspection coverage. Using an automatic encoder improves accuracy and repeatability in data acquisition. Inspecting from both sides with 2 transducers increases detection probability and reduces dead zones. Together, these practices maximize the reliability and quality of phased array inspections. If you found this video useful, like, subscribe, and follow us on social media for more non-destructive testing content. See you in the next video.